The circuit's on. Input volts, amps. It only draws about an amp and a half. So that's where it is when it's off. And then if I reconnect this over here, it goes up about an amp and a half. Alright, so I put a Red Bull can on the top as top load. And it draws about a ½ inch before it extinguishes. While it's on over here, it's off over there. It's the copper's actually red hot, and the heating is. I had a little bit of wax actually on this terminal, and it melted into a puddle yesterday. But that's the secondary, and it's about a ½ inch gap between the actual coil insulator and this coil form. Right. And they're the exact same coils. I got them from the same guy off eBay so that I would have references. Gary Bluer, I think is his name. There's a plug. Woohoo. Anyway, I bought another one over here. This one actually runs, it's got 4 turns. It was 20 bucks, all pre-assembled. It runs at a little over 2 megahertz, as it is. So I need to work out the dynamics between how this one's wound and set up versus how these are set up. It's the same transistor, same diode. That one's got an LED in the circuit, no LED on this side. And this is running currently at, I've got 300K resistors all in parallel, so about 33,000 ohms. And over there it's a single 100K resistor. I did play with this resistance, increasing it to like 300K with 3 in series instead of all in parallel. And it made very little difference to the actual running frequency. What it made a difference to was the input current. So the lower this value, the higher your current. And there's probably, if you have a pot that you can plug in, you can probably sweep through the resistances and find different points where the current's higher or lower at specific resistances, because it doesn't seem to be linear. I mean, it's at 33K now. When I first was playing with this, it was at 2.6K. All right, so it's way lower. And in that instance, it ran at about an amp off of the current there at the same voltage, as opposed to what it's running at now with the 33K, which is closer to amp and a half. Although it's interesting because it all feeds through there, so I can't really separate it. This light, it's on and off. It also draws about an amp, about a ½ amp, I guess. In any case, this is purely inductive, right? There's no physical connection of the cable between these coils. The bottom of this coil on the left comes out at the back, and it's just free-formed in the air, and I tucked it up under the top lip of this PVC and then ran it up over this edge to create that little, that's about a ¼ inch gap. That field doesn't let my fingers work the zoom very well on the video, but you can see that that's what's drawn there, right? And that's purely inductive. That lamp, NE2, is also not connected. It's just sitting on the table. It's not physically connected. It's just picking up whatever's in the field there. So, I mean, it seems like one might set up 2 different ones of these. So if I have a third coil, which I do, if I have a third coil and I wire these 2 guys with kind of the same gap, and then I crisscross primaries, so I put the primary on this one, but I use this primary wired in concert with the other secondary, and the primary on the other secondary I would use with this secondary. The other curiosity is that just free scoping the coil, if I put that on the it's set for 10 times, 10x, but the frequency that's picked up on this coil, this one's running at about 470 kilohertz. This one picks up at about 1 megahertz, a little over a megahertz. Let's see this. So we keep the ground free floating. It's not going to touch anything. Lower voltage, so it's it's going to make me a liar, huh? That must have been what I was picking up before. That's touching just the top of the probe. Alright, that's what that is. And at that resolution, you can see that it's closer to the megahertz. Helps that my hand isn't also coupling to the other field from the source coil. If it's over here, then it's coupling more and it's causing a decrease in the actual frequency. So there we go. That's what's happening. And I'm also holding a screwdriver in that hand, which is probably also coupling, which is causing other weird effects. So. Look at 1.19. We're at 250 microseconds. Sorry, nanoseconds. At 200 volts, so it's 350, 400 volts on that coil at 1 megahertz. Alright, and that's what we're looking at here. I've ended up pushing it too far over. Back. I don't know if you can pick that up. Getting a little spray there. Pretty good, the scope doesn't explode. Pick up that hissing. It's not quite moved back close enough over here. It needs to go over a little bit more, and then it'll induce the plasma arc between there. network's established, it's quiet. So it's curious, huh? That this wants to run at a megahertz as opposed to the 470 kilohertz. It might be because there is no primary on that coil yet. I wonder if it'll go to the right frequency. It might put a coil over it, like another piece of acrylic, and throw it around it, put another primary on it. Have to see what happens then.